Hi, thank you. Thank you so much for coming out and spending the next hour and 15 minutes with me to talk about algebra. If you were in my presentation this morning, you're going to see some of the similar things when we talked about representations, and then I'm going to extend that and really delve into what that means to algebra instruction. So, without further ado, our agenda for today, I'm going to briefly talk about the research because we talk so much about research and practice and the importance of evidence-based practices. So I want you to know about the research surrounding manipulatives and concrete representational abstract or virtual concrete representational abstract sequencing when teaching algebra and teaching secondary mathematics. We're then going to talk about ways to incorporate instruction. I'm going to share with you 3 ways that you can kind of take what you're doing and take your expertise and really mold it and scaffold it to enhance instructional experiences for students, and then go through some examples. And I have videos and manipulatives for us to play with and all of that. So IES, the IES practice guide. And this, I know if you look in the corner, this says for elementary grades, and you're like, wait a second, I thought this was a secondary presentation. Don't worry, this actually works for secondary students as well. And the research supports using representations to teach mathematics to secondary students as well. But the IES practice guide, focusing on students who have challenges learning mathematics, one of the recommendations, one of the 6 main recommendations was to use multiple representations when teaching concepts and procedures. So the language that we're going to use when talking about this, I'm going to talk about concrete manipulatives. Concrete manipulatives are those things that you can touch, you can move around. These are kind of more of the elementary ones. We're going to be using algebra tiles today. So things that you're physically moving. Or virtual manipulatives, which are the ones online, which are some of the ones that I'll be sharing. We also have the semi-concrete, which are more of those visual representations, things that the students are drawing to support understanding. Okay. And the recommendations say that number one, have students touch and draw and engage with mathematical concepts and procedures. And also making sure that we connect these across. So it's not a sequence, as I said earlier, but really a flow from concrete or virtual manipulatives to semi-concrete and representations to those abstracts, numbers and symbols that we traditionally use. Okay. The third recommendation is to allow students to use manipulatives and representations as thinking tools. And I'll have an activity for us to play around with this as well. And then finally, revisiting ideas and concepts with manipulatives to kind of reinforce that. So when we're talking about maintaining understanding of skills and concepts and generalizing them, and as we know, building our skills as they become more complex. So thinking about concrete representational abstract, sometimes it's called CRA, sometimes it's CSA. You may see different things in the literature. But essentially it's that kind of hands-on drawing and then number and symbols. And I have this visual here because this is kind of how I think about it and think about the literature and think about this sequencing or this progress. So we have these representations, and that's going to be when you're introducing a concept, when students are in that acquisition phase, you're going to be relying more heavily on those as they're making sense of the construct, the idea. And then that slowly scaffolds away. So we're not necessarily using the manipulatives anymore. Students may still be drawing. And even within that representation phase where students are drawing, there's ways that they can scaffold into this more abstract because we want students to eventually be able to solve equations using those numbers and symbols and just kind of relying on representations as needed as opposed to heavily relying on that. So we'll kind of talk about that systematic scaffolding into the abstract. But the other thing that I want you to notice about this, the visual, is the abstract is there the entire time. Okay, early in my my CRA research, I thought it had to be use the manipulatives, then have students draw pictures, then have students write the equations. But it's really much more fluid than that. And there's a lot of research and more recent research that shows that integrating across these areas is effective. So you'll see examples of that as well. Okay. Talking about manipulatives, there's lots of different ways that, or lots of different manipulatives that are out there, things that you can buy, but you don't have to buy things. It can be popsicle sticks, or I should say it doesn't have to be expensive. It can be popsicle sticks. You can use felt and cut felt. There's lots of different ways to make inexpensive manipulatives as well. One of the things you'll want to note is making sure that the manipulatives you use, the representations you use, make sense to the concept. And then also I like to think about, well, how does it make sense not only to this concept, but to more general concepts, or how can I build off of this and do the tools that I'm using and I'm having students use because it takes time to teach them to use the tools. Can students grow with that with their concepts? Okay. So research shows that both concrete and virtual manipulatives, and kind of specifically algebra tiles are what we're going to be focusing on today, using those supports conceptual and procedural understanding for students with and without disabilities. Um, Essentially, they're good to use. Research supports using manipulatives and representations. Okay. So one of the questions I get a lot is, well, are virtual manipulatives better or like the physical concrete manipulatives better? And the answer really is any of them. I mean, use manipulatives first. So any kind of manipulatives. Research supports both virtual and concrete manipulatives. And then what are the students' preference? Emily Bach has done a lot of research using virtual and concrete manipulatives and comparing them. And some of the research says, hey, concrete manipulatives are better. Some say virtual are better. Some say that students prefer virtual. Some say students prefer concrete. So it really depends on what's available, what students prefer. I would say also what you're comfortable with. I am much more comfortable with concrete manipulatives. Um, when I'm doing things on the computer, when I'm doing virtual manipulatives, it's more challenging for me to like think and speak and move things on the computer than it is for me to move hands-on manipulatives. So I prefer concrete manipulatives. You're going to see some videos of that, but virtual manipulatives are easy. I'm going to share with you a lot of free resources, and students can use them at school. They can use them at home. They don't cost anything. So it really kind of depends on the situation, the content, the student, and your preference as well. Okay. The next few slides, I'm just going to kind of share different ways in the literature or different aspects of the literature where virtual or concrete manipulatives were used to teach algebra. So if you're interested in any of these articles, I'm happy, you can email me. I'm happy to share them. I'm not going to go into each one in depth. I just want to kind of show you different examples of the literature and the research out there supporting manipulatives to teach algebra. So shifting into how to incorporate it into your instruction. The research supports using it. I'm going to go over 3 different ways that you can incorporate it into what you're already doing. The first is through explicit instruction. The next is using worked examples. And then the third is using video modeling. And all of the examples that I share with you today can really be applied using any of these techniques. And oftentimes they overlap as well. So you can use explicit instruction to teach a worked example through a video model. It's really flexible and can adapt to what works for you and your students in your classroom. Thinking about explicit instruction. So there's a lot of research out there showing that systematic and explicit instruction is really helpful and supports students' learning, especially when we're talking about students who have challenges learning mathematics, students who are struggling with mathematics, and students who need extra scaffolds and supports to master the concepts. So if you think about the anatomy of a lesson, that's kind of what I have here. You would start off with a conspicuous review. This is where you're overtly making connections to previously learned materials and kind of priming students' knowledge. For example, if you're multiplying positive and negatives, and students have already learned that a positive times a positive is a positive, and positive times negative is a negative, you may want to use kind of easier problems to review and prime that so that when they see the equations or the expressions and they have to do that, they already remember that. Oh, yeah, I've done that recently. I know how to do this. Okay. And then there's modeling. So, modeling is demonstrating, sharing metacognitive talk, sharing examples, share non-examples, but it's a lot more than just telling students what to do. I shouldn't say it's a lot more than. It isn't just telling students what to do. Modeling is really that opportunity where you can show, engage in discussion, ask questions, monitor students' progress while showing them in modeling how a problem is done, the concepts, steps, procedures, ideas, vocabulary, any of those things. And throughout this time, you're providing feedback and extra practice. And then we get into guided practice. And this is where you're starting to give students a little more freedom, a little more opportunity to take it, share what they know. Sorry, I'm kind of getting tripped up on words here. So you have this guided practice where students are, rather than just kind of answering the questions, they're starting to ask the questions, or they're prompting themselves for what the next step is. And you're becoming more and more confident that they're able to do it independently and successfully. So we have this like scaffolded practice. One of the challenges I see with explicit and systematic instruction is sometimes we go from modeling to independent practice and really skip over that guided practice, which is an important step. Another thing to consider is during that guided practice, students may be showing that they're ready for independent practice at different times. So one student maybe after the modeling show that they're ready for independent practice, but you have a lot of other students who really need more examples, really need you to kind of talk through it more. Really, they need to talk through it more as well. So when you have these groups where students are moving at different paces or they're at different paces ready for independent practice, it can get frustrating as a teacher. Trust me, I remember this and I know this as a teacher. What do I do with my students who are ready for the next step, who are ready for independent practice when I have others that aren't? One of the things that I like to do is have a small group. So after I'm done with my modeling and my whole class instruction, students that are ready for independent practice can do independent practice. Students who maybe want some peer practice can work with a partner. And then I usually work with a smaller group where I'm able to monitor the instruction a bit more and monitor what they say and provide more direct feedback. So this is kind of like an overview of an explicit systematic lesson. And if you're using manipulatives and algebra tiles, you'd be modeling how to do that. You'd be using that metacognitive talk to talk through what you're doing and why you're doing it. One thing I want to really emphasize here is that modeling is not lecturing. So it's not just talking at students, telling students what to do, and then having them do it. Modeling is really a discussion. Go to the next one. It's providing self-regulated talk. It's providing opportunities for choral response, for independent response. It's providing feedback. It's engaging. Sometimes I hear that modeling is boring. And quite honestly, we can, as instructors, make anything boring. But you can also make anything really engaging. And if you're teaching students at their at-right level, and engaging them in this process, it's not boring and it's not lecturing and it's challenging to students at the right level. When I think about the dialogue within modeling, I like to think about it through that cycle I have here at the bottom, where you start off where you're sharing a piece of information, and then you're asking a question. This is really a monitoring question. And then you listen for responses, or you look for responses if you're doing something visual. You monitor the responses, you provide feedback, and then you share another nugget of information. Okay. What's interesting is I am not going to be doing that in these presentations. And even the videos that I show you, it's not share a nugget of information, ask a question to engage students, have the response, and provide feedback and continue in that cycle. It really is just share, 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 share. But if you use any videos or something like that in the classroom, what I would do is if I had a video that was just talking, 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 I would stop the video and ask a question and have the students answer it and then continue on. One of the other things I want to share, kind of like a non-example for today's time together, is that I'm the examples that I'm showing you the entire problem all at once. And that may be a little much for some students. So one of the ways that you can scaffold instruction is to chunk it down into smaller parts. So rather than having a really long problem and being like, we're doing all of this problem right now, you can chunk it into smaller parts and have students practice and master the different steps and then kind of put it all together. So there's different ways to differentiate this systematic instruction within your classroom. Okay. Here's another example of using virtual manipulatives, and kind of I want you to see kind of different ways that virtual manipulatives can be used. In here again, you have a model of what you can say in the dialogue that would happen in the explicit instruction. In this, there aren't those questions that I talked about in that cycle, but you can put those in and you can include those and add those and really make decisions based on the students in your classroom and how quickly the pace should go and how often you're going to stop and ask questions so you can make those data-based decisions in real time. Okay. And then here's another example. And if you notice in this one, we have the virtual manipulatives, the drawing representation, and the abstract numbers and symbols all together and right next to each other. So this is really that integration that I was talking about. And then what would happen is you start scaffolding, you're not using the virtual manipulatives anymore. So students are just drawing the pictures and then using the numbers and symbols. And students will eventually self-scaffold so that they may not be drawing as much, or they're only using the drawings and representations when they're kind of thinking through the process in a different way. So I tend to see that students self-scaffold in that representation element. Okay. Here's another example of a graphic organizer that I created for lessons that I did where we had word problems. And then we used the manipulatives. I had a place for them to draw the pictures, a place for them to solve the problem, and then connecting it to the number line. So again, just showing another way that you can integrate that CRA or that VRA within one lesson. Okay. So next thing I want to kind of talk about, which is secondary teachers, you know this, so I'm going to spend just a minute talking about this, but skills progressing across grades. By the time students come to you, by the time students are doing algebra, they have had a lot of mathematics already. And so those foundations within number sense, how they're making sense of addition, subtraction, multiplication, division, uh, really kind of impacts learning algebra. When we start working with the manipulatives, you're going to see, hopefully, and I'll try to make those connections to, hey, remember in elementary school, students did this or this part of multiplication, doing the area model. This is how it connects to algebra. Okay, in this sequence I share here, we have those manipulatives or kind of the objects. Like students can start making sense of math without even knowing the numbers and symbols that we use. So we have these objects. And then In that green arrow, we connect those objects and those magnitudes to squiggles. And we say this squiggle is a 4, and this means 4, and this is a plus sign, and this is a 6, and equals 10. And then we start building in complexity. So now we're working with place value. And then we get to that purple one with algebra. And rather than saying we have two known numbers, we say we have a known magnitude plus an unknown magnitude, which equals a different magnitude. Okay, so skills progress, and we one of the things that we experience as teachers is if there are any gaps in students' number sense, we often see that when we're working in algebra. So using the manipulatives can help address some of those skills as well. Here's another example of just kind of how what's happening in elementary school can then scaffold into algebra. And this is similar to an activity I used to do with my kids when they were in preschool. We would use these manipulatives, and then I would have a certain number of manipulatives, and then I'd have another set, and I would say this 2 plus something in my cup is the same as 5. How many objects do you think are in my cup? And then my kids would tell me, and we would check it. Okay. The cup, the unknown, really represents that X, that unknown in algebra. So even in preschool, kids can start to understand those algebra concepts. Okay. Now we get to the fun stuff. That was a lot of, oh, why are we doing what we're doing and all that kind of stuff. Now we really get to the fun stuff. So, and if you, this is the part to kind of, in the chat, we're going to share different websites. And the website I am going to focus on is Polypad Amplify, which is there as well. You can type it into your browser. I'm going to give you in just a few minutes, I'm going to give you some time to explore this site because this is like a super cool site. Whenever I introduce this to teachers, this is like the mic drop. They're like, this is amazing. I love this. I can't wait to use it. On this page here, I've just highlighted a few of the really, really cool features that Polypad Amplify has, and it's free, by the way. So you can watch videos. They show different videos about how to do things. You can move all of those algebra tiles. They have the positive, they have the negative. You can do fun things like negate them. We'll play around with this. You can change the background, you can change the color, you can record. It's really neat. So what we're going to do now is, and I'm going to have, there are going to be opportunities for you to use this in the future. But what I want you to do now is we're going to do a quick 5-minute exploration. And then this is what I tell my students, it becomes tools, not toys. So whenever I introduce manipulatives for the first time, they play around with them for a set time. They can do whatever they want. And then we transition to tools, not toys. And the reason I'm doing this, yes, thank you. Amplify offers training on Polypad as well. The reason I'm doing this is because there are so many cool features, but I don't want you to feel like you are kind of playing around with those features and trying to listen at the same time. So it is 2:40. At 2:45, I'm going to keep going. Okay, so you have 5 minutes to play around, get a drink, take a break, and I'll see you back at 2:45. I'm going to mute my audio, but keep my video on. If you have any questions, now's a good time to drop them in the chat as well. We have about one more minute, and there's a question in the chat that I will address as well. Okay, it is 2:45. Welcome back. I hope you found some really cool things in there and some cool features. Every time I go into Polypad Amplify, I kind of find a new thing that I like to play with, and they're constantly adding things. One of the questions I had in the chat is, what do you do when students in eighth grade or maybe 2 to 3 grade levels below where they should be? And that is that's always a challenging one. I'd love to kind of I can happy to talk with you kind of individually as well to see what this means to your students. Um, So one of the things I think we need to do is kind of think about, and you would have to like prioritize, well, what, because we don't have time to reteach or pre-teach everything. So really, where are the priorities? What skills, concepts do the students need that they don't currently have to be successful in algebra? And kind of focus on those. I think with that priming of information, sometimes dedicating some of that time to like reteach those prerequisite skills prior to going into the regular skills. And I know there's so many factors that play in, because then you're like, well, I have my pacing guide that administration wants me to follow, and this is the curriculum, and I'm not allowed to veer from that. But I think because time is such a valuable and limited resource, making sure that you're making data-based instructional decisions. So really targeting those skills that the students need that they have challenges with. Using manipulatives is going to kind of help address some of those things as well, because when we jump into algebra, it is really abstract. So making some of those connections with those concrete manipulatives to easier skills would be something as well. Um, if there's more specifics, I'd be happy to kind of like delve into different areas. Another thing you can do is kind of scaffold what we have, or if language is one of the challenges, scaffold the language in the activity, really thinking about like the activity and what you want the objective to be. Like, what is your objective? And how do you make sure that you're kind of prioritizing that and removing other barriers? For example, although I wasn't going to go down this rabbit hole, math facts. It is super important that students know their math facts and kids know their math facts, and it really reduces the cognitive load when we get to more complex things. And not knowing your math facts fluently should not be a barrier to higher order mathematics and algebra. So, if I'm focusing on an algebra concept and I really want them to focus on that concept, I am fine with students using a calculator or a multiplication page, or even kind of having that information, because I don't want them to focus on that at that time if my objective is the more complex concept and procedure. Worked examples, we'll see that coming up, might be something to address as well. So I will think about that and continue to think about that as we move along. What's going to happen now? We're transitioning into what I think is definitely the more fun part of this presentation. And these are the problems that I'm going to go over and we're going to talk about. And you now have those virtual manipulatives. You can play along and do that. I have some videos where I'm going to show you using the regular manipulatives. And yeah, and I'm happy to stop for any questions. So before we get started, or I should say, as we're getting started, this is a good one to start with. If you're using the virtual manipulatives, they are very similar to the concrete manipulatives. Color may change, things like that, depending on what brand you use. If you don't want to buy these, you can go get felt and cut out felt or cardstock or any of that kind of stuff to kind of make your own. But we have, this is X, this is negative X. Negative X is red, X is green, yet our constant, our unit of 1 is off-white in my set, and the negative 1 is red, and X squared for me is blue, negative X squared is red. So interestingly, in my set, all the negatives are red and all the positives are different colors. This is one of the ways that you can scaffold if you want. So these algebra tiles, you can put on there, this is X. I just used an Expo marker on some of my other sets. I've used Sharpie and I say that's X. You're not going to be able to see it in the brown as much. That's negative X. So if students need that extra visual to know that this is x, this is negative x, you can do that. This would be negative x squared. I can write it right on there. Okay. I can write 1 or negative 1. So that's one way to kind of scaffold that. Here we have 2 plus x has the same value as 5. I like to say when I see the equal sign, I don't like to say equals. I like to say has the same value as, because we're really working with balance. So this is one of those pre-skills, those prerequisite skills. Sometimes we think equal sign means solve for. And then when we get to algebra, the unknown variable is anywhere, and we're really trying to find balance. So instilling in the students that the equal sign means balance. And so 2 plus x has the same value as 5. And here's my first video. Fingers crossed that it works. Excellent. This does not have audio to it because my daughter did not want to talk. But here you can see video where she is setting up the problem. And it doesn't have to be perfect. And then you're going to see how she solves it. In future videos, I solve it in different ways, but she set it up and then she said, okay, 2 plus x equals 5. And then she took away 2 from both sides to get x equals 3. Oops, there we go. If you're using virtual manipulatives, you can't necessarily just take away, but one of the really cool features that Polypad Amplify has is, as you see it here, you have your positive and your negative, and then you can do a 0 pair. And if you move the negative over to the positive, you can kind of see there that it shows you it's 0. So it doesn't disappear, because it doesn't disappear in mathematics, but it shows you that it's that 0 pair, which is super cool. Okay. And again, as I'm going through these, please feel free to play around with them on your own as well. One of my goals is that you see different examples so that if you choose to use them in your own classroom, it's kind of demystifies what's happening when using the algebra tiles. Okay. Another way, I said explicit instruction is one way to introduce using algebra tiles and manipulatives and algebra. And here is another great thing that you can incorporate into your instruction. And this is a worked example. So in a worked example, the steps are already completed for you. Okay. This allows students to really focus on what is happening. So if I see 2 plus x equals 5, I've already solved it. I already have the answer there. Students don't need to put their energy into that. Instead, what you're doing in a worked example is you're teaching students to evaluate what is happening from one step to the next. So from 2 plus x equals 5 to 2 minus 2 plus x equals 5 minus 2, what is happening? What's happening in that abstract numbers and symbols column, and what's happening in the representations column? So how is that, what's visually happening there? And then there's a column for students to explain as well and kind of tell what's happening. Now, there's lots of ways to differentiate worked examples in your classroom. One of the ways to do it is to fill in different parts of the table. So in the worked example, the problem is worked for you. But maybe you have 2 of those what is happening rectangles filled out, or you want students to draw one of those steps and show what's happening in one of those steps. So you can have different parts of this table blank or missing and have students fill those parts in. You can also scaffold the language. If vocabulary is one of the challenges or the access points for learning mathematics and expressing things mathematically, you can include a word bank. You can have provide examples. You can have, say, like, use these terms or use these phrases when explaining what's happening. Okay, or if writing is a challenge and I don't want students to spend too much time writing, maybe this is already written out and they kind of connect or move it. So cut and paste or copy from a table where they get to select it. So there's lots of different ways that you can kind of differentiate. I always say it goes back to what is your objective? What do you want students to get from this? You can also highlight, color code. This is a simple example, but you can apply this worked example structure to any of the problems that you have. Okay. I'm going to pause just briefly. Questions? Okay. If you notice, we're starting off simple and we're moving to more complex. Here's my daughter again, kind of showing how she solved this problem. The reason I have the page there with like the blue marker is to show that it doesn't have to be professionally made or printed. Like this is just something I took a piece of paper and a marker and created. The concept, the understanding is still there. So here she's showing 2x on one side has the same value as 10 on the other side, and then dividing that into two equal groups. Okay. It's always fun to watch children and see how they're doing this because she just, as you see there, she kind of just divided it half, the top and the bottom. She already had it in an array. Sometimes it's all scattered and students have to move it. So it's really fun to watch different ways that students are making sense of this information. Okay. And now we start getting more complex. So here you have the 3x plus 1. I'm going to share another video. This one, my daughter's actually talking through it a little bit. Um, so,
Uh,
so I'm not going to talk.
3x plus 1 equals 10. 3x plus 1 equals 10. And then minus 1. And then 3x divided by 3. And then 9 divided by 3 equals 3 equals x. X equals 3.
Okay. So now the next video that I have to share with you is me talking through this problem. This is a more complex problem. And just a little kind of going into this, I created the videos because I was concerned that if I was doing it in real time and trying to manage everything, I would make more errors. But like anything, I think if I watch this video 10 times, I'll find 10 ways to improve it. So as I'm sharing these videos with you, one of the things that I want you to do is think about, oh, I like that. Maybe I would do this differently, or I would say this differently, or I would make these changes. But really kind of think about, well, what you like about that, what would work with for you in your classroom and your students, and then what changes you would make. I think if I watch a video 10 times, I'd probably make at least 10 changes each time. Maybe not each time, but close. So they're not perfect, but they provide the examples. In this one, I'm using more metacognitive talk. So I'm talking through what's happening. If I was using this in the classroom, I would pause it at certain times and ask students kind of questions, gauge their understanding, have them use expressive language to talk about this. Sometimes I would use choral responses, either visual or oral. Sometimes you may want to call in a one student at a time. Okay. Other things you can do in ways that you can scaffold this, especially if the first three videos were my daughter doing this. If students are doing this, even in Polypad Amplify, like they can record what they're doing and you can watch that, or they can take screenshots of different parts of what they're doing. So there's ways that you can use this for formative assessment and understanding that are not as traditional as just filling in a worksheet.
In this video, I'm going to solve the algebraic equation 4x plus 3 equals 2x minus 5. And I know the equal sign means I need to balance. So 4x plus 3 has the same value as 2x minus 5. To help me remember this, I'm just going to draw that line segment right there so that I know I have to balance both sides of the equation. To solve this equation, I want to isolate x. Okay, so I want to get my variable on one side and my constants on the other. First thing I'm going to do is set up my problem. So I have 4x, and that's a positive 4x. So I'm going to put 4 x's right there, plus 3 has the same value as positive 2x minus 5, which I know is the same as adding negative 5. So that's what I'm going to do here.
That might have been one of those prerequisite skills that I
have to
primed
keep
before
track
this lesson.
what I'm doing down here as I move the manipulatives up here. So the first thing I'm going to do is I want to move all my constants onto one side. So how do I get these constants onto that side? Well, I have positive 3. So I'm going to subtract 3, or in this case, add negative 3, or 3 negative units. Okay? But I want to balance my equation. So I need to add 3 negative units to this side as well. Okay? So it remains balanced. Now here, when I have, with my constant, I have a positive unit and a negative unit. And I have a 0 pair. Positive 1 minus 1 is 0. So I can remove my 0 pairs from my board. Okay? Now I have 4x has the same value as 2x minus 8. But I still have my variables over here. So what I'm going to do is I'm going to subtract 2 x's or add 2 negative x's. So what did I add to my board? I added 2 negative x's. And I want to keep that balanced. So what am I going to add to this side? 2 negative x's. And you can do that just like this. Now, just like my constants, I want to make sure that I have a 0 pair. So negative x and positive x, that's a 0 pair, I can remove that. Negative x and positive x, 0 pair, I can remove that. And I can do this on this side as well. Negative x and positive x, remove that. Negative x and positive x, I can remove that. So now I have 2x has the same value as negative 8. And here, my coefficient is 2. My variable is x. I'm going to divide this into 2 groups so that I can isolate x and just get 1 x there. So I divided 2x into 2 groups, and now I'm going to divide my negative x equally between these 2 groups. Okay. Here, I have each x has the same value as negative 4. So x equals negative 4.
Okay. So in that, let me go back, but I do not want to play that video again. In the video, if you notice, I kind of walked through the different steps. I talked about the positive, the negative. There may be parts of the video that you're like, oh yeah, I like that. Parts of the video you're like, oh, I would have said that differently or done that differently. That's totally fine. Okay. And if you notice, I did do all of the steps at once. If I was working with students and it was more challenging, we would probably chunk it. and we might do kind of the first few steps. Or if I paired this with a worked example, we would have the worked example, and then I would do the steps. So there's a lot of ways. Yes, you could use this as review. I'm sorry, I'm jumping into the chat as well. If there's yeah, anyway, this is to give you ideas so that you can think about like, oh yeah, I can do this in my classroom and I can do this and I can make this work for me. Okay. Any other questions? Excellent. Okay. This next one I don't have a video example for, but you can see I started with, on the previous one, I started with kind of that positive, and here I'm adding some more negatives. So I still have the negative numbers in the last one, but here I'm adding a few more negatives. I'm making it a little more complex. And in this example, you can see how the steps happen within the polypad amplify in the way that I did that. Okay. And again, I recommend as you're doing this, go in and try it out and move them and see what you would do. I have a question about students in grade 9 and 10. Have you seen this? Yes, I've absolutely seen this work for students in grade 9 and 10. I've worked with high school teachers, and actually I was observing one of the teachers using Polypad Amplify. And it's so interesting. I love watching students, and I love watching students make sense of it. And I love that the teacher did this lesson for me to observe. And one of the students that struggled the most in the class was totally glued to what the teacher was doing. And it was so interesting because I was walking behind this student, and this student is watching what the teacher's doing it and doing it themselves and just on track and making sense of it. I went into an eighth grade classroom, and I was just recently, so it was the end of the year. They had already learned the concepts. I was kind of mostly teaching or like demonstrating to the teacher how to use them and working with the students. But even working with those eighth grade students, you're walking around and they're like, oh my gosh, this makes sense now. And like, I get it. And so even though they were taught kind of more of that abstract procedures, I could see them making the connection with what was happening. So absolutely this would work for ninth graders and 10th graders. I am going to get into like multiplication and stuff too, and kind of show you how that works as well. Um, what happens when 2 is divided by an odd number? That is a great question. And I'm going to leave some time at the end to get back to that, because there's different ways that you can address that. So I will get back to that as well, because you can use these for fractions, and use algebra tiles when talking about fractions. And there's different ways to do it. So you kind of have to do it in a way that makes sense for you. Okay. So next thing I want to talk about is the distributive property, or when we have binomials and expressions. And traditionally, I don't know about you, I was taught the FOIL method. First, outside, inside, last, right? Mnemonics really work when you memorize them. And it wasn't until I was an adult teaching mathematics that I really learned that that is a shortcut that expires. So teaching the FOIL method is great when you have problems like this or expressions like this, but what happens when you start having trinomials and it doesn't fit like this? So even though we sometimes try to simplify things and make things easier for students, and the FOIL method is a way to do that, what I recommend is really get to the heart of the distributive property. And what is the distributive property and how to make sense of the distributive property, rather than memorizing to first, outside, inside, last. which only works when you see problems that look like this. So here's our problem, x plus 2 times x plus 3. And I love when working with students using kind of like little folders like this. And this is a organizer that I created for these types of problems. I'm going to show you the video is going to demonstrate using that and how to set this up. Again, take what you like from the video, improve it the way that you can improve it.
In this video, we're going to simplify the expression x plus 2 times x plus 3 using algebra tiles. My graphic organizer has a place for us to write the expression and read it, a place to show our work, a place to draw a representation, and then a place to write our simplified expression. So the first thing I want to do is set it up. And I have x plus 2. So I'm going to set up x plus 2 times x plus 3. And those are all positive, so I'm making sure I'm using the positive side of the algebra tiles. If I was to draw this, it would look like this. X plus 2 times x plus 3. Okay? And if you're like, this looks a lot like the area models that students do in elementary school, yes, this is one of the ways that we can build that early elementary or that elementary multiplication into algebra. So now, traditionally, we would teach students to do the distributive property. X times x plus x times 3 plus 2 times x plus 2 plus 3. But here we're going to show it using these tiles. So we have x times x, and that gives us x squared. And then x times 3, we're taking x and we're multiplying it by each unit. So x times 1 equals x times 1 equals x, and x times 1 equals x. Next, we're doing 2 times x. So here we have 1 times x equals x, 1 times x equals x, and then we have 2 times 3, or the way that we have the pictures here, 1 times 1 equals 1, 1 times 1 equals 1, and then we do that 6 times.
There's a reason why I used small numbers,
We've used the algebra tiles.
because this could take a lot of time when doing these examples.
And what we have here,
I recommend that when thinking about the examples for the students.
we have x times x. We have x times 1, x times 1.
And I am aware that it is 3:15 and we only have 15 minutes together, and I want to have time for answers. So
I would take more time to do it.
So I'm going to move on from that, but that way you can kind of see how to set that type of problem up. Here's another similar problem, but this one has that negative number. Again, I would prime that when you're multiplying a negative times a positive, you get a negative, and kind of show and demonstrate how you have that here. With this type of problem, I recommend you kind of playing around with that and trying this problem on your own. Okay. Another thing that we shared is that manipulatives can be used as thinking tools. So if we have this quadratic equation, if you set up the manipulatives and the tiles so that you have 1x squared, 6 x's, and 8 units, which is what I have there, x squared plus 6x plus 8. And then you can have students use these to make a square. Okay, or use these to make a rectangle. And it's fun to really watch students kind of put these together and think about how to do this. Going to the chat, would this work for the distributed property in general? Absolutely. And there's going to be a slide coming up that'll kind of make that connection as well. So eventually, it's this slide. So eventually you're going to, as students are making the square, this is kind of what I would say I would kind of be looking for. But there's different ways that students can make the squares and or make this into a rectangle. And that facilitates conversation. So what happens if they put the X's kind of in different places? You still get the same answer, you just kind of simplify it. It's just not simplified. But here we built the square and then I'm showing, okay, we have X plus 2 times X plus 4, which is that inverse of what we were doing before. If you think about, so to answer the question about the distributive property, yeah, I mean, this connects to what students do with area models in elementary schools, so, or in elementary grade levels. So you can, rather than having that X, you can really replace this with any numbers, and you can kind of show how that works. Okay. Another way that you can do or use this, sorry, I was reading the chat at the same time, is through video modeling. So I've showed you lots of videos. There's different ways that you can use videos in your classroom. You can have students watch videos. You can have students watch videos as a whole class, and you can stop the videos and you can have conversations, or you can model different ways or ask different questions. You can have students watch videos independently. Maybe this is one of those distributed, this practice activity. So we've taught it as a class. Now you're going to independently watch a video and solve a similarly structured problem. Okay. The videos I have are like 4 minutes. I would say the longer the video, the the less likely students are going to watch the whole thing. But if you create or you find videos that move at that good pace that show the steps, and then you can have students watch the video and solve a similarly structured problem. Okay. I just kind of added a few examples at the end here to show you, so you have access to these. I'm not going to go over how to do these, but I do want to get time to address the questions. Okay. Factor quadratic, thank you. Going to the chat right now, students can absolutely make their own videos. You can collect screenshots. You can have students make videos for other students. This is a great way to kind of address peer modeling. I have a question about 5 times x plus 3. Absolutely. So kind of going back to that type of problem, if you just had, this would just be 5. Let me see if I can. I'm going to try to annotate here. This is where I'm going off script, so we'll see if this works. Draw. Okay. This here, rather than having it x plus 2, this could just be 5. And then that would just be 5. I don't know why it's not working or it's disappearing. I think I did something for the, anyway, so you could have, maybe I can do it over here, 5 times x plus 2, and then do that distributive property. See, this is where technology is not always my friend. X plus 2, and then do 5 times x equals 5x plus 5 times 2 is 10. That's going to do it again, and then do 5x plus 10. So there's absolutely ways that you can adapt this to the distributive property in different types of examples. And you have so much expertise in mathematics and all of this. So thinking about like kind of tapping into what you know and how you do this, and kind of using these manipulatives to kind of enhance what you already do well is great. Oh, see, now I'm on the drawing app. There we go. Okay. This is why I try not to go rogue in presentations, because then I start messing up. So it is 3:22. I want to take a few minutes to just kind of make sure that I address questions. We can talk over some other examples. So if you want to stick around, please do. If you're like, I got it, thanks for coming. I hope you just kind of take what we've done and really make it your own, and get kids engaging in mathematics and touching math.